the electric spark. We would learn about what is resistance of system of resistors, heating effect of electric current and electric power. Resistance of system of resistors. In various electric gadgets, we often use resistors in various combinations. Ohm's law can be applied to a combination of resistors. There are two methods of joining the resistance together. They are 1. Resistors in series and 2. Resistors in parallel. Suppose I is the current and V is the PD across points C and D. R1, R2 and R3 are three resistors connected in series between points C and D. Then Rs is the effective resistance in the circuit and V1, V2 and V3 are the potential across the three resistors such that V is equal to V1 plus V2 plus V3. But using Ohm's law, total potential difference is V is equal to IRS and V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. Substituting these values in equation number 1, we get IRS is equal to IR1 plus IR2 plus IR3. RS is equal to R1 plus R2 plus R3. For number of resistors connected in series, then we get Rs is equal to R1 plus R2 plus R3 plus R4 plus Rn. Let's take one example. Find the total resistance and current in the circuit. Solution. In given example, resistors are connected in parallel along with 4V battery. The three resistors are 5, 3 and 2 ohms. Total resistance R is equal to 1 upon 5 plus 1 upon 3 plus 1 upon 2. So R is equal to 5 plus 3 plus 2 upon 5 into 3 into 2. So it comes R is equal to 10 upon 30 ohm and is equal to R is equal to 1 upon 3 ohm. The total resistance in the circuit is 1 upon 3 ohm. For calculating current in the circuit, the formula is I is equal to V upon R. Here, V is equal to 4 volt and R is equal to 1 upon 3 ohm. Then, I is equal to 4 upon 1 by 3. So, I is equal to 4 into 3. I is equal to 12 ampere. The current in the circuit is 12 ampere. Now we will study about heating effect of electric current. The production of heat energy in the conductor by electric current flowing through it is called the heating effect of the current. Joule law. The quantity of heat, that is H, is generated in the conductor of resistance, that is R, when a current, that is I, passes through it for a time, that is T, is directly proportional to the 1, the square of current, that is I, 2, the resistance of the conductor, and the third one is the time for which the current flows. Now, using Ohm's law, we can write H is equal to I square RT upon 4.18 calorie. That is, H is equal to V square T upon 4.18 R calorie. It comes H is equal to VIT upon 4.18 calorie, where H is equal to heat generated in conductor, I is equal to current passing through it, R is equal to resistance of the conductor, V is equal to voltage of the conductor, and T is equal to time for passing through conductor. Application of heating effect of electric current. In an electric circuit, the unavoidable heating can increase the temperature of the components and also alter their properties. However, heating effect of electric current has many useful applications. The most common examples are electric iron, electric toaster, electric oven, electric kettle, and electric heater. An electric bulb consists of a filament. This filament becomes hot and emits light. It is made up of metal with high melting points such as tungsten. Electric power. Power is the rate of doing work. Similarly, electric power is the electrical work done per unit time. Electrical power is also defined as the rate at which electrical energy is consumed. One watt is equal to 1 joule upon 1 second. Formula for calculating electric power is equal to power is equal to work upon time. So P is equal to W upon T. But W is equal to V into I into T joule. So P is equal to VI T upon T. That is, P is equal to VI, where V is equal to voltage and I is equal to current. Let us solve one example. An electric bulb is connected to 250 volt. The current passing through it is 0.27 ampere. What is the power of bulb? The solution is, in given example, voltage is 250 volt and the current is 0.27 ampere. So, P is equal to VI. P is equal to 250 into 0.27. So, P is equal to 67.5 watt. And the power of the bulb is 67.5 watt. Summary 1. According to Ohm's law, resistance of system of resistor can be applied by two ways. A. Resistors in series and B. Resistors in parallel. 2. Resistors in series are used to increase the resistance in the circuit. 3. Due to heating effects of electric current increase the temperature of the component and also alter their properties. 4. Electric power is the electrical work done per unit time. And that is all in the lesson. Learning is fun, so keep learning.